Right, I'm going to move away from Climate Studio because basically you can learn Climate Studio from the tutorials that are online. And it's a really, really cool piece of software, but it does one job, basically. On the other hand, it is possible, I'm just going to come over here and tidy up this particular area. Let's just hide some of these things. Um, I'm usually much more interested in using the digital for sort of somewhat more expressive, kind of exploratory things. And one of the things at the very beginning is that I have talked, I've mentioned a couple of times, there's a tool called Grasshopper. And the way I've mentioned it is that you'd be very tempted to get involved in Grasshopper because it looks like it could solve a whole load of problems for you. The reality is that Grasshopper can create more problems than it solves. However, I didn't want to leave you at the end of this semester without having given you some idea of what the way Grasshopper works and specifically the way parametric approaches work. And I'm going to define what I mean by parametric approaches. I'm going to use some good examples. But the way to think about it is this, and I've shown you how record history works, which is basically like you go through a process and you can tell Rhino to remember that this thing is related to this thing, and then when I change this, I want this to update. That's one way of thinking about a design approach. But basically what happens when you do anything in Rhino, let's just say, I've got a curve on the ground, and I want to divide that curve into an equal number of segments, let's say 20, and now I have 20 of these segments, and I have all the points I need on this curve here. And then I do a whole load of things with those points. Maybe I have a line that comes out of that point, and then I want to copy that line to all of these points here. Boop, 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 boop. And it's fine. It doesn't take me long. I can do all of this. I could imagine maybe this is like the beginning of, if the line was going up, this would be like a handrail or something, right? And here I am, and I've messed one of them up. Let's just fix that. There we go. And now, let's say I do a few more things, but then I change my mind about how many points I wanted at the beginning. Well, this is a linear process I'm in. So now, instead of 20 segments, maybe I want 25. And so what I have to do is I have to say, oh, well, okay, well, none of that's working anymore. So I'll get rid of that. And then I'll find all my points, cell points, and I'll delete those. And I'll come back to here and I'll divide that again. And I'll type a different number now this time. And then I put my line in. And then I copy. Anyway, you get the idea, right? It's going to take me a while to redo something if I change my mind about my starting point. Because Rhino is a linear process. It's like modeling with clay. You can't model with clay and then get to the end of it and then wish you'd started with some different material. Well, you're stuck. Now, parametricism is a different way of approaching this same question, which is we can fire up a tool called Grasshopper. All you do is just type Grasshopper. And this is going to be a very, very high-level introduction to Grasshopper, but give you some examples. The first thing I want to say about Grasshopper is the best rule for when Grasshopper is a useful tool to you is if you have already done it in Rhino yourself once, at least once. Probably a few times. Because the reality is that Grasshopper offers you something that looks like an acceleration effect. However, it takes longer to set something up in Grasshopper than it does to just do it in Rhino manually, usually. It's only if you know that you want to explore some set of options where you want to be able to keep changing your mind about the initial conditions. So here I am, I'm going to kind of bring Grasshopper over. Basically, Grasshopper opens up in this whole new window, and then I'm going to take Rhino and put it in this window and just collapse down my layer panel a little bit. Here we go. And now what I have is two windows, and the two are kind of linked. And what you can do is almost identical to Houdini. You remember I gave you a little intro to Houdini where we were doing things with like smoke and simulations. You put down nodes and you connect them with wires. So it's a process where you visually represent like a recipe that you're telling Rhino to like cook this recipe. And at the end, you say, okay, I'm done, give me my output. And in fact, there's a really nice parallel, Grasshopper at the very end of the process. The way that you then put that stuff out of Grasshopper back into Rhino is you do something called baking. It's like baking a cake. So imagine that you're effectively, you are now going from, when you're in Rhino, you're the chef, you're like controlling everything that's in the Rhino viewport. Now, Grasshopper is the chef, and you're just saying, I want you to do this, 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 and this, and then bake me out some food. That's effectively what you're doing. So the first thing is I need to be able to get geometry from Rhino into Grasshopper. And the way we do that is by double-clicking on this canvas here, and we enter a search keyword, and I'm going to bring in a curve. I know I'm going to bring in a curve, so I'm going to bring in that. And when it comes in, I've just double-clicked, and I typed curve, and I chose curve there. And what this does is this holds one or a collection of curves that exist in the Rhino viewport. They could exist anywhere, but for now they're going to exist in the Rhino viewport. And what I want to do is I want to right-click and do set one curve. In this case, I could do set multiple curves if I had multiple, but I'm going to do set one curve. And then I come over to Rhino, and you'll see that Rhino command has changed to say curve or edge to reference. So I'm going to select this curve. And now it's turned green, and this thing has turned green. That tells me that this curve is now sort of stored in this little node. That node thinks of itself as that curve. And if I click away, it'll go back to being black, and that's black. But if I select it, it'll highlight it in this window. And remember, there was a recipe that we did. With Rhino, what we did was we clicked on the curve, we typed divide to split it into a whole load of points and segments, and then we started basically copying a line to each of those points, or whatever we wanted to do. So what I'm going to do here is I'm going to do exactly the same thing, and usually the command that you write in Rhino exists as an option within Grasshopper as well. So this is why the rule is, if you're going to do something in Grasshopper, do it in Rhino first, manually, and document your process. So you say, right, I know I'm going to select this line, I'm going to pipe it, I'm going to loft two lines together, I'm going to divide this curve, I'm going to extract that iso curve, I'm going to do this, or whatever it is, whatever your process is, you document it, and then you come into Grasshopper and you are going to lay out that process. So the divide curve node accepts in three inputs, two inputs that it absolutely needs to have. One is the curve that you want to divide, and the second is how many segments you want. So what I'm going to do is I'm going to drag my mouse, or click and drag my mouse, from the output of the curve to the input of the divide curve node. And what that will do is say, this is the curve I want you to divide now, please. I'll just pause there for a second. Do you want me to go back over anything, or you got any questions about this? You kind of follow me so far? This is basically me saying, if it was a recipe book, that this node would be like mix with a spoon. But mix with spoon doesn't work until you know what it is you're mixing with a spoon. So you need to tell the thing not only to mix with a spoon, but what it is that you want to mix with a spoon. And then here we've got a count, and by default it just comes in and it says, oh, well, probably 10 is a good number, I don't know. So it doesn't know until you tell it how many segments to divide your curve into. But what you can do is you can type in number slider. Number sliders are cool because this number slider, I can double click on the thing that says number slider and then set up a few options. So for example, I'm going to do integers. I don't want decimal points because it's weird to divide a curve into 3.2 segments. Like, no, it's either 5 or 6 or 7 or 8. They're integer numbers, so I want numbers. And then I want minimum and maximum. Maybe the maximum is going to be up. We drag this up to 50 and press OK. And now I've got a number slider that I can slide between 0 and 50. I can slide this around wherever I want it to go. And then that's going to output a number. And this little dude here, it can go into count. And now I can divide my curve by any number between 0 and 50. And each time I do that, it's as if in Rhino, I just click the curve, type divide, and said how many things I wanted to do and press enter. But obviously Grasshopper is doing it super, super, super quickly compared to how long it would take me to do it in Rhino. Are you following this approach? Okay. The thing is, just pause there for a second. How long did it take me to divide the curve the first time? 10 seconds. How long did it take me to set up the Grasshopper connection of nodes that now gives me the ability to do that? A couple of minutes. So if all I wanted to do was divide a curve a few different ways and explore some options, it's still quicker to do it in Rhino, even though now I have this slider that makes me feel like I'm doing everything really, really quickly. However, Grasshopper becomes more powerful when you know exactly what the steps are that are going to follow that and all of the things that are going to be redone every time you change that slider. So let's imagine, here we are, we've got, I don't know, these are all the things, and then we've got maybe another curve that goes like that. Because now what we can do is we can use that same number to divide two different curves. So I'm going to select that curve. I'm going to say curve here, and I'm going to set that one curve. So this curve is that curve is that one, highlighted in green. And I'm also going to drag and tab Alt, same as copying in Rhino. I'm going to divide this one. So I'm going to divide this curve by 19 as well. And now both of my curves are being driven by the same slider. All very good. And now what if I wanted to take each of those points and draw a line that goes between the two of them? So now I can say I want a line, and the line here, create a line between 2 points. That's going to ask for the start point and the end point of a line, and then draw a line between them. Well, that's useful, isn't it? Because I can say line, start point are going to be all of the points on this curve. End point, that's going to be all of the points on this curve. And now I've got the ability to control all of those lines with just my instant slider at the beginning. Now this may be a little bit more useful because now actually that's something that if I wanted to change my mind about exactly how many points I wanted to have, then maybe it would take me a little bit longer to build that thing. Now what if maybe I don't want a line in between there? What I want to do is to put a midpoint in between those two. And actually what I'm going to do is I'm going to use the average. No, I'm not. Can I do midpoint? Yes. what I want is, in my mind, I've got an idea now that maybe this is going to be like an archway made up of structural kind of pipes or something. And so what I want to do is I want to take the midpoint of that curve, but then I want to lift that up into the sky. So now I'll go curve middle. I'm going to take the middle of that line, and that will put a point in the middle of that line. So now I've got 3 points, 1, 2, 3. And instead of a curve, what I could do is move all of those midpoints. So I've taken that midpoint and I've got a move tool, which is just the same as me clicking and dragging with the M button in Rhino. But it's asking for this thing called motion. And a motion is a translation vector. This is where Grasshopper starts to get a little bit confusing for most people, because it's going to ask for things. And if in Rhino, all you do is basically like click your mouse one time here and one time there to say, in this direction, please, you think of that as just clicking your mouse a couple of times. On the other hand, the computer is actually turning that into something that it really understands, which is a vector. A vector has a direction and a length, a magnitude. And so what we can do is we can find the unit z vector, which is the unit vector parallel to the world's z-axis, which is up. Z goes up. If we're not sure, we can look at this little guy down here, which has a z, y, and x. So I can type my unit z direction and wire that in. And then that introduces a factor. And that factor, maybe I want it to be a number around 3,000. So I've just typed in a number. And now you see all of these points are now up in the sky. What's interesting is each time I've done something, in Rhino, if I move something up, it moves, right? Like it starts down here and then it goes up here and it's not there anymore. Well, with Grasshopper, what you're looking at is each of these kind of points in the history of the recipe are still present, they're still turned on, they're still there. And obviously, they're all referencing back to the previous node. So I'm making like this network that takes me from the start all the way down to the finish. And if I change my mind, all of this is going to update. So it's got this kind of connection as the memory of what's going on. However, maybe I don't really want to be able to see that curved midpoint on the ground. It's not particularly helpful for me to be able to see that. So I can right-click and turn off the preview for that, and it goes darker grey. Similarly, with this line, maybe we turn off the preview there. And now what we have is a set of points at the beginning, a set of points at the end, and a set of points in the middle. And what we can do is we can do a curve control point curve. Oh, come on. NURBS curve. There we go. Sorry, I knew it was called something. NURBS curve. NURBS curve is the same as this kind of curve. Remember back when I introduced NURBS, non-uniform rational B-splines, not something you need to worry about. A NURBS curve is just a control point curve. And what we're going to do is we're going to say, right, we start with these points, and then we go to these points. And what I can do is I can wire in 2 wires into one place as long as I hold down the Shift key. And now I've got a curve that runs, here we go. And then this is the last one. Now I've got a problem, which is that these points are being used to create a curve, and then it's kind of jumping over here and then using these points to create a curve, and then it's kind of jumping over here and using these points to create a curve, and that's not what I had in mind. What I wanted was a whole load of curves that start, middle, end. And so what I need to do is I actually we'll just disconnect all of those. And what we're going to do is do something called graphed tree. What this does is my inputs are a whole load of points, but what comes out is something called a tree. And the tree lines are different to the point lines. This is just a list of points. This is actually a data tree that is basically every single one of those points is now its own start of a list of data. So rather than just here's a list of points, it's gone, here's a list of points coming, and there's one point in it. Here's another list of points coming, and there's a point in it. Here's another list of points coming, and there's another one. And we're going to do exactly the same thing to all of our other inputs. So I'm going to graph that one, and I'm going to graph that one. And so now what I have is I hold down Shift and Shift, is each one of these is going to match up with each one of the other ones. So now I can basically use each of these sets of 3 points as an individual line. That's what the tree command, or the graphed tree command does. And what I'll notice is because it's a NURBS curve, my control point being 3,000 millimeters above the sky doesn't mean that the line ends up being 3,000 millimeters above the sky. So I might have to bring it up a little bit more. And now I've got a complete parametric design for the structure of this particular sort of archway thing that I might want to be interested in building. Happy with that? Yeah? Are you sort of just like aware at this point now that you might be getting towards the point where you think, I don't want to have to click that 50 times. Wouldn't there be a nice way for me to be able to programmatically create a process that allows me to change my mind about my starting conditions, but does all the clicks for me? Well, this is that solution. However, you'd be surprised at the number of times when it doesn't actually really help you as much as you thought it was going to. And the first thing you need to do is you need to know what it is that you're asking it to be doing. I'll just turn these guys off so we can see it a little bit more. Then I want to show you one last thing that you can do with Grasshopper, which you can't easily do in other ways. I mean, there are definitely ways of doing it, but this number here is super simple. It's just saying move everything up by a number. However, what we could do is we could have that number change over time. Like, for example, we could have that number be characterized by some kind of mathematical function. And so what I'm actually going to do here is I'm going to use something called a graph mapper. Graph mappers are really, really useful tools within parametricism. And I'll just increase this number so you can see a little bit more. There we go. And what we can do is right-click on the graph mapper, go to graph types, and find sign. This is a super simple one. This is basically going to be allowing us to change this sine wave. The sine wave can either have a particular amplitude and a particular frequency. That's basically what a sine wave is. It's like a cycle. And if you remember from something like GCSE physics, this is like the vibration of a string, like in a musical instrument or something. Now, a sine wave is quite difficult to draw in Rhino because it's a particular mathematical function that doesn't actually, I mean, you can definitely draw one, but it's much easier to just let the maths do the maths. And this, because we've got control over numbers within Grasshopper, and we're using numbers to drive a particular design, anything that's like a mathematical function suddenly can become part of our design process. So I'm going to take this output, and what you'll notice is that I want to have an input here that basically the inputs are going to be along the bottom, and then the outputs are going to come out as values between 0 and 1. That's not particularly helpful for us just yet, because we've got this number that's like, it's got to be 6,000 millimeters in the sky. So what I'm actually going to do is I'm going to say I want 36 values. And in fact, I want as many values as there are on this slider. And I want the output to be the values between 0 and 1 that correspond to that graph as I draw it. Okay, so what I'm going to do is I'm going to make a range of numbers, and the domain is going to be the start and end. So 0 to 1 is how it comes in normally. I'm going to construct a domain. Construct domain. The domain start is going to be 0. The domain end is going to be whatever that number is. So now I have a domain that goes between 0 and 38. And then I want the same number of steps as there are here. And then here we go. Now I've got numbers between, if I want to see the output, I just type 2 forward slashes to get a panel. And there we go. I have numbers between 0 and 38. Useful. Well, the thing with that is that actually my graph mapper wants inputs between 0 and 1. So I don't actually need it to do that at all. I could take that completely away. I can leave my domain as standard 0 to 1, and then take this range into here. And these are just going to give me equal numbers between 0 and 1, split into 38 steps. I'm using that to feed into my graph mapper. And then I want to take the output and I want to remap that number. So these numbers start with a source domain of 0 to 1, but the target domain is where I want to construct domain. The target domain is pardon me. I want this to be the number where the output isn't between 0 and 1, the output is between 0 and 6,000 millimeters up in the sky, or whatever it's going to be. So here's my domain end. There's my target domain. And then these map to numbers. Let's have a look at how they've come out. Whoop. There we go. These look more like it. These are sort of decent sized numbers. And what I'm actually going to do is I'm going to take these mapped numbers and feed them into my factor of my unit vector. And now what I get is a graph that I can use to control the output of how tall each one of those each one of those curves is going to be. And I can also allow that to move around and play with those numbers however I see fit. And that is something you definitely could not do very easily just within Rhino, which is why it's worth spending the time in Grasshopper to get that set up. Yeah? Now that's quite complicated. I've kind of probably lost you about 5 minutes ago, but hopefully you get an idea that if what you're doing is something which you can drive by mathematical functions and numbers, we could come in here and have a different kind of graph. We could have like a parabola. There we go. And we could talk about moving things around, and you play with this to your heart's content, right? All of which would have been much more difficult to produce using Rhino. But because now we're in a world of maths, and if you're comfortable with the world of maths, you can use maths to drive that. Probably that's going to be the kind of thing where this is all recorded. You could follow this along, pause the video, say, what on earth has he just done there? Why does that work? Try and recreate it. Have a play. And see what fun you can have. Is that a quick intro to parametricism? This is why parametricism looks the way it looks, because it's mostly driven by mathematical functions. Questions? A few maths nerds in the room excited about going and playing with this, maybe. It's okay if not. This is just showing you it's there. This is a tool that you don't have to use, but it might be useful for you if you find yourself doing something very mathsy. Given this is the last time I'm going to see you before Christmas, are there any other questions about anything to do with the rest of the course, any of the tasks, any of the portfolio questions that you want to look through? How's it going so far in terms of using the digital in your design? Yeah? I mean, the nods it suggests that you are using some digital tools within your design modules. Are you? How is that going? I mean, just general. Like, it would be really nice to see. Like, are there people who are like really much more focused on hand drawing at this stage, or are you getting much more into the digital stuff within your design tutors? Maybe a mix. Yeah. So some of the things maybe I showed you last week about drawing, that's potentially worth going back and having a look at in terms of if you've got a particularly hand drawing focused design studio, but you're thinking, how do I even use the digital tools? Well, actually, they could be something that really helps elevate your drawings or becomes part of a hybrid. You never lose the pen. Don't put it down. Okay. Well, I'll be here for another 10 minutes. If you've got any questions or things you're struggling with, feel free to grab me. Otherwise, we will meet back up after Christmas and we talk about more things you can get out of the digital realm. Cool. All right. See you soon.